Cloudera Navigator Optimizer is the newest addition to Cloudera Enterprise, providing active data optimization for Hadoop success. First, let's take a look at what it actually means to have a successful Hadoop deployment, both for the big data architects and for the database administrators. This starts with a successful offload. Navigator Optimizer can help identify suitable workloads for Hadoop, providing detailed recommendations on how to offload these workloads correctly. Most importantly, Navigator Optimizer eases this overall offload process by providing the right insights and risk assessments to help reduce the overall development costs. When the workloads are running on Hadoop using tools such as Hive and Impala, database administrators need visibility to understand usage and optimize data models to service the ever-changing data needs. Navigator Optimizer provides comprehensive usage information, such as top tables, top columns, and identifies problematic areas in the queries to help make recommendations to enable peak performance. Part of the challenge that these two audiences face is the huge query volume that comes from having many different users and many different workloads running with lots of different technologies. For some companies, this can mean having millions of queries generated every day. These queries can be extremely complex, especially a lot of these legacy queries that have been modified and extended over time. BI tools can also generate very complex queries. To understand this usage and access patterns, such as joins from these complex queries, can be extremely difficult. And profiling the most common patterns in a large workload can be manually impossible. Navigator Optimizer can help break apart these complex queries and help you understand which ones are compatible with Hadoop, see where to start optimizing in complexity, and help understand this true development cost of offloading. So let's take a look at Navigator Optimizer in action. Here we have a use case where a large financial institution is looking to move all of their reports generated from a BI tool from DB2 to Hadoop. They have hundreds of these reports, and they want to minimize the disruption to their business users during this offload. They've already tried to run a couple of existing reports on Hadoop, but some of these reports haven't come up. They suspected that there may be join problems, but they can't be sure. They also want optimization recommendations, such as aggregate tables, to boost performance. Let's take a look at how Navigator Optimizer can help to offload these reports safely. First, let's look at the dashboard and get some basic workload insights. As we can see, this workload has around 6,500 queries, and we detect 88% duplication, which means only 12% of these queries are unique. This could mean some reports are running very frequently. High duplication could be quite normal for frequently updated BI reports. Knowing the duplication in general helps us focus the analysis on unique queries. Now let's take a look at top queries. We see that by instance count, or how many times the queries were executed, 3 queries are taking up a large percentage of the workload. We can also see that there are 2 tables that are most commonly accessed. When we look at top queries by elapsed time, we see that a handful of queries take over an hour to run, with 5 taking nearly 10% of the entire workload. This indicates that some reports are taking quite a while to run. Workload complexity is also a great indication of how easy or difficult this offload could be. So let's take a look at the join intensity chart, where joins are profiled by the number of join tables in these queries. This chart shows most queries have a reasonable number of joins, which means they won't require data model changes to run on Hadoop and Impala. For the few shown here that have many table joins, those will need deeper analysis and denormalization may be required. Now that we understand current usage a bit better, let's go back and take a look at how we can start to offload these reports. Back in our main dashboard, we can group queries by a number of different variables. Here, let's look at them by report. So we can see that a majority of reports have some high-risk queries associated with them. There are a couple of reports, such as report 19, that are low risk. These reports can be easily brought up to Hadoop without any changes. Of all the reports, report 143 generates the most queries, nearly 5,000 queries. Most of them are high risk, but there are only 5 unique queries here. This report probably gets run many, many times. So now let's figure out what's causing these queries to be high risk and how we can fix this situation. We can add all these queries in report 143 to the design block for a deeper analysis. There are a total of 6 queries with 5 high risk and 1 medium risk. So let's evaluate this risk further and see what's causing these high risk alerts. As we can see, for all 5 of these queries, they all do Cartesian joins. These can be very expensive, especially when the tables are quite large. For moving these workloads over to Hadoop, Navigator Optimizer can also help make suggestions to help adjust these risks. For these queries, though, we can reconfigure the BI tool to not generate Cartesian joins. For the medium risk queries, we see that these queries use a common filter. Selecting the right partitioning key is very important for Hadoop. If we scroll down, we see that Navigator Optimizer has recommended designing a new partitioning strategy and has a partitioning key design module that provides recommendations on the right partitioning keys based on common filters and popular joins. Once we eliminate the Cartesian joins and we pick a new partition strategy, this high-risk report can now be run on Hadoop safely. Once active with Hadoop, it's important for database administrators to continue to have visibility into usage and maintain peak performance for Hive and Impala workloads. In this example, this DBA noticed that one of their Impala clusters is running slower than expected, and they want to use Navigator Optimizer to figure out what's going on and how they can improve that performance. Here, they uploaded over 4,300 queries. This workload has a duplication rate of 42%. We also see here that nearly half of the queries are select statements, and the other half are inserts. This seems to be pretty high, and we can see that most of these inserts are single inserts. When we dig in deeper and take a look at top queries, we can see that the top 5 queries contribute to 25% of the workload. These are all also inserts. From the top tables, you can see that there are 558 inserts into this table, but hardly any selects. So why are we spending 25% of the workload to insert data without reading any of them? We can understand some of this complexity by looking at the join intensity chart. A majority of these queries don't have any joins, which is good news. This is pretty common for ad hoc workloads. However, we do see that there are a few queries that have many table joins. In fact, we see these 3 queries that have 15 table joins. We can dig into these 3 to get a better understanding of what's going on here by adding them to the design block. So here, when we evaluate risk, we can see that there are many table joins, which we already expected, but we also see that this query has no filter. So not only is this query using many table joins, but it's also not using any filters. This could be part of the performance issues that we're seeing. Now, in order to get the complete picture here, let's look at the risk assessment across the entire workload. We see that there are a total of 783 high-risk unique queries that are worth a deeper look. By looking into the design block for these unique queries, we find that there are 5 high-risk areas. First, we see that these queries have no filter, and this is for a majority of the queries, so this can be a major cause of the performance issues. These queries would need to be rewritten to add filter conditions. As we saw in the join intensity table, there are many table joins for many of these queries, so this is an opportunity for denormalization. We also see that there are many inline views, so this is another opportunity to materialize these views to simplify the queries and improve performance. In addition to inline views, there are other kinds of query blocks that I've also presented in large queries. And then finally, we see that Cartesian joins are found again. So now the DBA has the information that they can communicate with their users to fix these issues. These are all possible development areas that can help improve the performance of these queries. We can also look at the queries by user to see if there are any patterns to help narrow down this communication and some of these best practices. As we can see, our top users actually have pretty good coding practices and are writing low-risk queries. However, we also see that there are some that are writing more high-risk queries than others. User 5 in particular runs a majority of high-risk queries. So let's analyze this group of queries by this user to see what's going on here. So when we look at the risk assessment for these 96 queries, we can see that this user needs better coding practices. Their queries need the right filters, and the necessary join conditions need to be added so that it runs optimally on Hadoop. Navigator Optimizer has some recommendations for this user that the DBA can evaluate to help improve performance here. Whether they need to design a new partitioning strategy, denormalize tables, materialize inline views, or aggregate tables. These are all possible recommendations to help improve performance. Navigator Optimizer lets DBAs understand the usage within Hadoop so they can focus their optimization efforts on high-risk queries and provide recommendations based on Hive and Impala best practices. This helps them ensure peak performance for these workloads on Hadoop. Cloudera Navigator Optimizer is now generally available for customers with the appropriate Cloudera Enterprise licenses at optimizer.cloudera.com.